Opie plants 15 seeds in a potting mix. Experience has shown that for this type of seed, the germination rate is approximately 85%. Let x be the random variable, the number of seeds that germinate. So here, if x is the number of seeds that germinate, then it follows a binomial distribution with 15 trials and a probability of success of 0.85. So we want to start with the probability of x being 10. Now, we'll always have the class pad available for this type of thing, so let's just use the class pad. I'm just going to clear everything I've got there at the moment. And let's just move it across the side here. So we know that that's going to be an interactive and it's going to be discrete, and a single value is a PDF. And so 10 with the number of trials 15. Probability of success is 0.85. And that is 0.0449. So 0.0449 if I go to 4 decimal places. Now we want 10 to 15, but be careful here. That one's a less than. So that's the same as x being between 11 and 15 inclusive. Remember that we're dealing with discrete random variables. This will be different when you look at continuous random variables. For discrete, if x is more than 10, the smallest value that x can be is 11. So we now want to go back to the class pad, and it's a discrete, and this time it's a CDF because it's a range of values. So that's going to be 11 to 15 with 15 trials. Probability of success 0.85. And that is 0.9383. So 0.9383. We now want the expectation of x, and remember we know that that's just NP. And so that is 15 times 0.85. So once again, we just need to calculate that. So we've got 15 times 0.85, and that gives me 12.75. And now we want the standard deviation. Now the variance we know is NP1 minus P. Now we already have the NP, which is 12.75. And in this case, since the probability of success is 0.85, the 1 minus P is 0.15. So all I'm going to do is multiply my last answer by 0.15. And that gives me 1.9125. And of course, that was the variance. And so the standard deviation is the square root of that. So we'll do the square root of my last answer, and that is 1.383 to 3 decimal places. And then finally, we want the probability of x being more than or equal to 13, given that it is more than or equal to 11. So this is a conditional probability. Probability of A given B is equal to the probability of A and B, in other words, both conditions, over the probability of the second condition. Now, to be greater than or equal to 13 and greater than or equal to 11 is just greater than or equal to 13. So this is going to be the probability of x being greater than or equal to 13 divided by the probability of x being greater than or equal to 11. So if we go to the calculator and we use the fraction template, and I'm going to go to distribution, discrete, and it's a binomial CDF from 13 up to 15 with 15 trials. Probability of success is 0.85. And let's OK that. It doesn't like it because I haven't put anything in the denominator. That's absolutely fine. And we can just drag that into the denominator. And then all we need to do is make the first one 11. And then that goes from 11 to 15. And that is 0.6440. Correct to 4 decimal places.